Hello everyone. Now today I'm gonna make a kind of short video. Actually, it's mostly going to be a showcase. Um, I basically was working on the whole implementing the animated level part business, and I have made quite a lot of progress. And I was about to start making like my first tests. When I came across a problem with the implementation, which was the fact that collision parts for the static level data and collision parts for the animated level parts use a different system to store the information, which was going to be quite annoying to have to patch because I was reusing the collision generation functions that I have made for the static level parts, right? For the animated level ones. So that was going to be a headache. But the important thing is that while I was working on this, right, I came across, well, trying to remember how it was all implemented. This is my Magicka Map tool, right? Um, I'm gonna have to rename this actually because I call them worthless loops because we didn't know what they were before, but now we know. So basically, let me search for these collision materials classes, right? So animated level parts contain collisions start within a collision material byte, which has a corresponding enum. So you read a byte, which tells you what kind of collision material is used by that surface, right? And that is actually very useful information because we can read that they contain stuff like generic surface, gravel, grass, wood, etc. There's one called reflect, which I assumed would correspond to reflective surfaces, such as, for example, the mirrors in the Stars Are Left when you fight against Cthulhu, right? So those assumptions were actually correct, and I will demonstrate it in game now. So basically, we come over here to where we have the other part of the map. We're gonna go to Blender actually. We can see that our collisions for objects have collision layers, right? And when we have a collision layer, we have values from 0 to 9 because there's 10 collision layers. And we didn't know what each collision layer did. But if you realize the enum actually has 10 elements, and these collision layers are 10 layers in total. So then it clicked. That's what these collision layers are. Rather than using a byte to encode these, they use for some reason an int32, which stores this value, which corresponds to like what index in the list it's meant to be stored, right? So you have like, rather than storing a value to save what the correct surface type is for each collision, they have 10 loops over the static level data. And it's kind of weird, but it kind of makes sense if you think about the fact that every single animated level part is isolated to one single collision type. The entire level has to be able to handle tons of different collision types. And so rather than limiting every binary tree root node or node in general to being isolated to one single collision type, they decided that the main level structure, the level model, is going to contain 10 lists in total filled with collision meshes that are identical, right? And each of those are in what we came to call quote-unquote layers, right? And that's why I did 10 loops in total. That seemed pretty weird. But now it makes sense because it means that on each loop they detect all of the collisions that correspond to one collision type. So collision 0 was always generic. And we can actually go ahead and make the floor be grass. So we could come here and we can say collision 0, 1, 2. This is going to be the value for grass, right? So I put in here this object right here, which has collision layer 7, right? And this collision layer 7 is a mirror. It should reflect the beams from our magics. So basically when we use magic for arcane or healing, it should be a reflective surface, so the beam reflects, and that's what happens. And this makes implementing animated level part orders of magnitude easier because we don't have to care about having to make this whole translation from layers to having collision layer values ignored when you are within a bone, blah blah blah. You just have to keep the thing consistent. That's it, right? So It's pretty cool. I'll have to think about how I handle the whole thing about meshes, each being allowed to have their own collision layer. So probably I'll make something like, you know, rather than geometry, I'll make animated geometry or something like that, right? Or maybe I add an option that says is animated, right? Which I had before, but I removed, and now I'm probably gonna have to bring back. So yeah, whatever. That way we will prevent the file from being generated in a way that is actually not valid. But anyways, the point is, we have this object with collision layer 7, and I'm actually going to go ahead and add a few more because I want to make some experiments and I want to see what happens. So yeah, this is gonna be kind of weird, but I really want to see what happens when we do something like this. Okay, it might even crash. Who knows? Who knows? Nobody knows. I don't know. But it would be really nice to see what the result is. So let's save this up and let's export the map to our JSON file. And I'll be back when I compile the map. Okay, so here we are back again in Magicka, and let's open up the level. Hopefully I didn't do anything wrong and it won't crash. And here we are. So I changed back to daylight because it's easier to see what's going on screen in the videos. And here we are. So this surface right here is the reflective surface that I was talking about. So if I throw a beam over the rest of the map, you can see that nothing happens, right? The beams just stay in there as they are meant to, right? So nothing special about any of these objects, but the moment I go over to this reflective surface, the beam reflects, and that is so cool. That is so cool, because we can have reflective surfaces that are both static and animated when I finally implement animated level parts. So this is so cool, and it reflects on every single surface, on every single face, you know, every single triangle of this object, which means that as long as the normal is the same between surfaces, it would be smooth sailing, but like, well, I mean, it's even smooth sailing across surfaces, right? But like, what I mean is that basically this means you can just have any object with as much complexity as you want. The game doesn't use this too much. They actually only have flat mirrors, I think, in the Cthulhu map, right? So it's pretty underused and wasted in my opinion, because this has so much potential. And you can see right here I added other mirror pieces, and these other mirror pieces, I'm not sure if this is a problem with the lighting here for all objects or only the mirrors, because these seem to be too dark for my liking. But we'll figure that out later. Anyway, look at that! You can reflect so many times. Holy shit! That was so cool. That is so fucking awesome. That is so insane. That, like, the fact that we can do this right out of the box, it's fucking cool. Just look at that. Holy shit. I'm gonna put the SQ red. Oh shit. That is really nice. That is really nice. And it's really good to be able to do this sort of stuff now, because we can very easily implement tons of things with this. We can implement tons of things. There's so many things that can be done with this. And it's so good. I'm really glad to know what the collision layers do now. And now that we know what the collision layers do, we can also change the surface type of objects to make them give the proper sound, because when we walk in here, you might not be hearing anything because my sound is very low, but the steps are not the correct ones. These are like generic ground, kind of a stony, I guess, steps, right? When it's meant to be grass, right? And we can actually get the grass sound like that. So that's a really good improvement. Like, that is a really great improvement. And I'm really happy to know that it actually works like that. Now, my question is, what even are the layers for lava and water? I have no idea. But this is going to be really good. We have to figure out what each of these do, and it's going to be quite interesting to research this sort of stuff. And it's pretty exciting to know that we're getting this far in modding. So yeah. Anyway, we got it.